Welcome to this explainer. So, if you've ever found yourself wondering exactly how engineers manage to perform what is essentially complex open-heart surgery on a highly pressurized live oil well without triggering a massive blowout, well, you are definitely in the right place. Today, we're going on an anatomical tour of wireline operations, breaking down exactly how this really ingenious engineering feat actually works. Let's just dive right in.
And just to make sure we don't get totally lost in the technical weeds, here's our game plan. We've got 5 quick parts. 1. Introduction and history. 2. Why use wireline. 3. Surface components. 4. Pressure and tension control. And 5. Downhole tools.
All right, Section 1, Introduction and History. Let's quickly look at where this whole thing started.
Picture this, the 1930s. This old photograph perfectly captures the super humble beginnings of the technology, back when a guy named Earl Halliburton first cooked up the wireline measurement winch. He originally developed this sidewinder unit from 1931 just as a really simple way to verify well depths and check cement levels. And from this kind of basic mechanical setup, an entirely new discipline of well intervention was born.
So, what actually is it today? Well, at its core, wireline is an incredible technique that lets engineers lower tools into a high-pressure well using just a single steel cable. We are talking about a perfectly smooth steel cable. A lot of times, they literally call it piano wire, that has 0 seams and 0 welds. Just think about that for a second. They're using this tiny, continuous, flexible wire to fight against absolutely crushing, explosive pressures deep underground. It lets them drop in tools, take measurements, and do vital maintenance, all without ever having to shut the well down.
Moving right along to Section 2, Why Use Wireline? Let's talk about the pros and cons of doing things this way.
The biggest, absolute game-changing advantage of wireline is the economic efficiency. Compared to hauling in a massive, heavy drilling rig, wireline has an incredibly small footprint. It's fast, it's highly mobile, and you really only need a crew of maybe 2 or 3 people to run it. But the real kicker is that last point on the list. It allows for intervention without killing the well. The oil or gas just keeps right on flowing while they work. For the operators, that translates to massive cost savings and uninterrupted production.
But you know, reality check, there are definite downsides we have to mention. Because the equipment is so minimal, the operators themselves have to be incredibly skilled to prevent a disaster. Also, wireline relies completely on gravity. So if a well is heavily deviated, meaning it curves way off to the side horizontally, or if the fluids down there are super thick and viscous, the tools simply won't drop. And if you hit a hard, solid blockage, forget about it. A flexible wire just can't give you the heavy mechanical pushing force you'd get from a solid pipe.
When conditions are right, though, it is wonderfully versatile. Operators use it for a ton of different typical interventions. We're talking tubing control and cleaning, running pressure and temperature logs, or placing safety valves. They even use it for what's known as fishing, which is exactly what it sounds like. If a piece of equipment breaks off and gets lost thousands of feet down in the dark, they use wireline to literally fish it out.
Okay, Section 3, Surface Components. Let's start our physical descent into the whole operation.
If you actually walk onto a job site, here is what you're going to see. Over on one side, you've got a specialized mobile truck. That holds the massive steel drum with thousands of meters of cable, plus the control cabin where the operator sits. And that works directly in tandem with a huge crane or mast, which hoists the equipment right over the pressurized wellhead. So the wire just travels from the truck, up through some pulleys on the mast, and straight down into the well.
Which brings us to Section 4, Pressure and Tension Control. How exactly do you control a thin wire plunging thousands of meters down?
Well, you use this brilliant yet totally simple piece of engineering, the Martin-Decker tensiometer. The wire passes through it, and it uses a deformable membrane. So as that wire pulls tight, it actually compresses a liquid inside the device. That compressed liquid instantly sends a pressure variation to a gauge, so the operator gets an exact, real-time read on exactly how much weight is hanging on that tiny cable.
And monitoring that constant tension is absolutely critical. I mean, think about it. If that cable snaps under the heavy load, or if it catches on a friction point and breaks, you have just created a multi-million-dollar problem at the very bottom of your well. Watching that tension gauge tells the operator everything: if the tool is sliding smooth, if it's jammed up, or if it's safely hit the bottom.
Now check out these tall vertical pipes. To actually get tools into a live well without letting all that pressurized fluid violently blow out, the cable passes through 2 main things. First, a stuffing box at the very top that seals tightly around the moving wire. And below that, a long tube called the lubricator.
It is literally just like an airlock on a spaceship. The tool goes inside, the top is completely sealed off, and then the bottom valves open to equalize the pressure. It drops the tool safely from the outside world directly into the high-pressure zone.
And sitting right below that airlock is your ultimate break glass in case of emergency fail-safe, the blowout preventer, or BOP. This sits right between the lubricator and the wellhead. If things go completely sideways, the BOP has these massive, powerful jaws lined with rubber. They clamp shut, gripping directly onto the stationary cable, instantly sealing the well and stopping a full-blown environmental disaster.
All right, Section 5, Downhole Tools. We've passed all the safety valves, so let's finally head down into the dark. The actual tool string doing the work down there acts kind of like a cascading mechanical arm. Number 1, it connects to the bare cable with a rope socket. 2, you add heavy steel stems just for sheer downward gravitational weight. 3, you have jars, which are basically sliding hammers that give you upward or downward impact force. 4, a knuckle joint to help all these rigid metal pieces bend and navigate tight curves. And 5, the specific operation tool itself.
Notice how all these parts thread together here. But here is a wild detail. They use special sucker rod connections that have to be tightened completely by hand with special wrenches. And, absolutely crucial here, they must never, ever be greased or oiled. That high metal-on-metal friction is the only thing ensuring they don't just unscrew and fall apart thousands of meters downhole.
And the physical size of this entire tool string, it is strictly, entirely dictated by the inner diameter of the well's tubing. It's exactly like threading a needle. The tools have to be perfectly matched to the pipe. If they're a fraction too big, they get stuck. Too small, and they might entirely miss the mechanisms they're supposed to be interacting with. It requires just an incredible level of precision.
Which leaves us with a totally fascinating question to ponder. We know wireline relies heavily on gravity, and we know it seriously struggles in highly deviated, curved wells. But with modern oil and gas pushing deeper and deeper into extreme horizontal drilling and crazy complex well geometries, how is this foundational 1930s technology going to adapt next? Are we going to see robotic tractors completely replace gravity? It is a super exciting space to watch. Thanks so much for joining me on this explainer, and definitely keep questioning the engineering all around you.